NFP a jejich vplyv na výkon a hospodárnost siete. Vysvetlíme si stručný rozdiel mezi aktívnou a pasívnou daskou, mezi malými buňkami reálnej datovej priepustnosti a dopadami na sieť. Takže ak ste pripravení, máte slovo a ja idem naháňať účastníkov na sálu.
Takže dobrý den, děkuji, že jste došli do sálu. Pro ty, co s kterým se neznáme, jmenuji Pavel Muzikant, pracuji ve firmě Fiber Optics, možná znáte ten název Optical Technologies. My jsme od 94. roku vyrábíme v Bratislavě vlastně všechno, co se týká pasivní optické konektivity, od základních optických komponent až přes modulární systémy VDM, TLC splittery, řešení pro datové centra, po řešení FTTX sítě a hlavně zákaznická řešení, to znamená, co zákazník potřebuje. V portfoliu máme i řešení jiných zahraničních firm a jedním z nich je systém aktivní DAS od firmy Jamie Wireless. Já jsem si dovolil pozvat sem na tuto konferenci Mortena, s kterým si znám mnoho let a spolu jsme zpracovali v předchozí firmě Connectivity, který znám názvem Fúzkou. Připravovali jsme několik projektů DAS v minulosti, již před 10 lety a možná i déle. Aktuálně se rozvody DAS řeší na pasivních koaxiálních rozvodech, bohužel tyto rozvody a toto řešení má své limity už 4G, na už pak s příchodem 5G vlastně je dá se říct potřeba používat systémy aktivní DAS, které běhají po optické páteři. Nebudu díl zdržovat, dám slovo Mortenovi a snad vám zkusit otevřít oči ohledně aktivní DAS.
Yeah, so you probably guessed it's going to be in English. So they have a beautiful lady here to help me with any questions and translating. So feel free to ask if you have any questions. So I think we are all very dependent in our daily life of the mobile phone, and I'm pretty sure you've discovered that you use your mobile phone maybe more and more for data. Of course for voice still, but more and more for data. Maybe watching movies, maybe uploading your pictures. So the need for bandwidth and the need for good, mobile networks is very, very important. Luckily for most of you guys in the room, these wireless networks will not work without wires. So for sure, a good optical network, a good transmission network with millimeter wave or wireless backhaul is important. But the last few meters from the antenna to the mobile is also critical. So I'm here today to spend a few words on that. And like Pavel said, historically as a DAS, so DAS is a distributed antenna network. So the way it works, it takes the signals and distribute it inside buildings like hotels here, because quite often, especially for 4G and 5G, with all the losses and all the clutter of the building will limit the data speed. So we need a solution for that. Quite often, especially we as technical people, we get a little bit carried away. So I quite often ask the technical people, so what do you really sell to the customer? Are you selling signal levels or are you selling data speed? And it's clear that we are selling data speed, so you need solutions that is delivering the maximum data speed at the lowest cost. Meaning that the solution itself might be 10 to 15% more expensive, but if that solution can deliver double the data, then the solution economy is very attractive. Everybody's talking about 5G. My advice to you and the audience would be, forget 5G for a while. It's going to take years before you see any real 5G networks out there. I'm going to talk a little bit about 5G. 4G for sure is going to be the core vehicle and core tool for us for many years in the industry to deliver capacity. On the wireless side, like any other technical solution, there's a few parameters we need to focus on. I can spend, easily 2-3 hours, maybe even days talking about these parameters. Very, very briefly, I'm just going to highlight that I advise to divide it into four main parameters here to make sure that you have maximum capacity and maximum revenue from the distributed activity region. As a mobile operator, it's very important. As a customer of the building, it's very important. One parameter is noise figure. Without being too technical, I would say this is the same as loss in the system. So the more coax you have, the more attenuators, the more loss you have in the system, the less capacity you have. So that would be the limitation for the passive solutions. Then we have some critical...
Morten,
yes?
Can I shortly interrupt you?
Yes.
Your speech is recorded. It will be available on internet.
Okay.
And maybe for some people which do not understand English language, I was asked to interrupt you, and maybe if the lady can say something.
Perfect. So feel free to jump in, but I understand it's going to be translated and available for the internet. Perfect. So we're going to be famous on the internet. Fantastic. So I'm not going to spend too much time on this, but please reach out to Pavel, and please reach out to Marcus, my colleague there in the corner. He's our VP of Sales here in this region, and we'll be more than happy to have further detailed discussions. But the signal performance in the network is extremely important, especially when we see new applications like high definition TV. You know, the cameras are getting more and more resolutions in the mobile phone, so you need more and more data data speed to support those pictures and those videos. So I try to break it down very, very simply, and you have to be patient with me for a while. So the radio planners and the mobile operators, they have the red parameter here to focus on, and then we have the performance parameter. And very simplified, you will see that the downlink capacity, so the capacity from the network down to the mobile, will be dependent on a lot of planning parameters, but it's also going to be very dependent on the grid parameters, especially as a thing like passive intermodulation. Briefly going to talk to you about this in the next slide. And like so on the uplink, so from the mobile up to the network, we have a lot of planning parameters that is in control of the radio expert and the mobile operator, but then the green parameters is extremely important also because that can degrade the performance of the network. I made a graph, and some of you might be familiar with 4G networks, but this is actually a way of showing the quality of a little simple thing as a connector in an antenna. If that connector performs very well, we call it passive interval, better than minus 160, you will then on your 4G carrier, 20 megahertz, with under these conditions, you're going to deliver 75 megabits per second. If the quality in the passive devices, the connectors and splitters and jumpers, just degrades a little bit, so let's say we go down to minus 150, your data speed will drop from 75 down to 50, or you're going to lose about 34% of the capacity in your network. Meaning that if you have 1,000 base stations out there, it corresponds to about 350 of those base stations will not be active, just due to a simple connector and the quality of the connector. And this is okay.
I'm sorry.
Okay, so there's going to be a little bit of translation or
it is required as it is recorded.
Okay, perfect. So I'll just continue. Okay. So the connectors, and again, we can show you this in more details, and Pavel can show you this in details, but a very, very simple thing as a connector is actually very complicated if you are to design it both from a mechanical point of view and electrical point of view to perform those minus 160 dBc and also be stable over time. So
Konektory, které vdávají pohledovat jednoduchá, ale věřím, jednoduché nejsou a to už mechanické a vlastně vydáme z toho obrázka.
Okay, perfect. And again, I can go on for days and Pavel can confirm this, but I'll just try to simplify it a little bit. So the way the 4G networks works is that it's gonna adjust the data speed from the network to the mobile depending on the quality of the radio channel.
Tak to spomínam, môžeme sa veľkých detailov, ale chcem to v podstate zjednodušiť. Prepojenie tých siete na ten mobilný telefón je hlavne o tom odpojení.
So here I'm just trying very simply to show two antennas in the same environment. The A is the antenna, and you can see that the dark green area is maximum capacity. The light green one is the next step. And you can see in a system with low capacity and low quality, you're not going to utilize the full bandwidth of LTE, so it's going to degrade your throughput in the network from day one.
To budeme vidieť v verejnom siete, Ačko je A ako antena a vidíme to napojenie. To znamená, že podľa toho, ako je technicky riešené, vidíme, že aký je prenosný.
But yeah, I have 50 slides on this topic. I'm not going to do that, but please visit our webpage and you can download a white paper on all these parameters.
Máme 15 slajdov, ktorí sa venujú len tomuto, takže do toho nechcem ísť do takýchto detailov, ale ak by ste mali záujem, samozrejme na našej web stránke si všetko to viete dohľadať.
So the way the mobile operators today covers buildings is that typically, like I'm going to show you on this slide, we have 5 buildings and they're going to deploy a base station, maybe 3G and 4G, operator 1, operator 2, operator 3. So a very complex network to cover these 5 buildings.
Tu môžeme vidieť mobilných operátorov, sú tu 3 rôzne mobilné operátory, ktoré robia 3G, 4G v 5 rôznych budovách.
And that prevents the mobile operators from investing in a lot of solutions for indoor coverage. So the way we want to do it is using our centralized NAS, where you use one of the buildings and then you just connect that capacity via your wonderful fiber solutions to a lot of buildings up to 20 kilometers away with one investment.
A toto môžeme vidieť na tom predošlom slajde, že je to veľmi komplikované a drahé riešenie, pretože je to zbytočne drahé. My sa snažíme to robiť v týchto indoorných riešeniach takým spôsobom, to znamená, že my v rámci tých sietí to riešime.
So radio performance is all about signal to noise. The better margin we have between the signal and the noise, the better the capacity.
Potom vidíme, že tu máme tzv. Napojenie signál a šum a závisí od toho, ako to máme, a podľa toho máme kvalitu toho signálu.
So here I'm trying to show the relation between the signal to noise up to 20 dB down to -5 and the throughput from 100% down to 5% in a standard 4G channel.
Tu môžete vidieť, že to je ten šum a kde vieme ísť z 20 až na -5 a vidíme, že je to rýchlosť tých údajov, ktoré sa prenášajú zo 100% až na 5%.
So if I translate this into reality,
Ak to teda preklopím do tej reality,
I can take a 10 MHz SISO LTE channel,
môžeme si predstaviť na 10 MHz riešenie
and I can map different signal to noise scenarios, and you can see it supports all the way from 37 megabit down to less than 2 megabit.
a potom môžete vidieť, že tie riešenia sa naozaj líšia podľa tých jednotlivých signálov. Takže ak môžeme vidieť 20 alebo 37 megabitových až po 1,85.
So we need to have the signal to noise up here in order to be efficient in the data speed.
Potrebujete hlavne dosahovať tú kvalitu toho signálu, pretože ten šum musí dostávať rovnaký.
So if I translate this into a number of users, I can take the same graph here with the same data speeds, and I take an average user, 0.5 megabit per second. I can see with this signal to noise, I can support 74 users, and then you can see 58, 37, 21, and so on and so forth.
Teraz to preklopím každého počtu užívateľov, ako môžete vidieť, je to od tých 74 až 4 užívateľov, a ako vidíte, tak v podstate ide o to procent, ktoré tam len 0,5 priemer.
So it makes a lot of difference in the terms of economy, and let's take it inside a building. So I'll show you a simulation here. So we have a tool that.
Takže vám to na takej simulácii konkrétnej, aby sme si to vedeli lepšie predstaviť.
So we take a standard office building and we build it up with the walls in a typical environment.
Toto sme predstavili, to je taký typický office, ktorý je 10 kartonov.
And we add interference like you can see on the red arrows.
Ako môžete vidieť, tu červené, to sú tie interferencie.
And then we can see what is the difference is if we do that same building with 4 small cells or one dash solution.
A potom už vidíme ten rozdiel, takýto office si rozdielíme na 4 menšie jednotky a bunky, alebo to dáme na tzv. GMA test na jednu pokrytie.
And as you can see here on the small cell, like on the graph before, there will be a lot of interference between the 4 small cells affecting the data speed.
Ako môžeme vidieť, toto je ten prvý príklad, ktorý sme videli, to sú tie menšie jednotky a budeme tu mať oveľa viac interferencie.
But on the dash side here, you raise the capacity, and we can talk about the numbers, but the network becomes more than 500% more efficient in terms of data speed to the users.
A v prípade tej GMAS máme oveľa väčšiu rýchlosť, aj celkové to pokrytie oveľa lepšie.
And then we have the other challenge. We have the challenge of the installation in the building. So I'm just going to show you a simple picture from a sports stadium in the US.
Že ukážem inštalácie, toto sú konkrétne príklady, toto je ten príklad jedného operátora v Amerike.
So here we have 3 mobile operators, with each having their set of different small cells and combining circuit.
Ako môžete vidieť, máme tu 3 operátorov a rôzne napojenia.
Or you can have one box that supports everything from 2G to 5G for all the operators, all the bands.
Alebo je to druhé riešenie, čo je to riešenie B. To znamená, že všetko to máte v jednom a je tam sú tam problémy tí 3 operátory, máte tam prekrytie 4G.
So I think I still have a few minutes left, right?
Mám tam celý minút.
So let's talk a little bit about 5G.
Poviem pár slovo o 5G.
And to be honest, I've been in the industry since 1986. So when people talk about 5G, I go, oh, here we go again.
Áno, my sme sa krátili v tom biznise ešte od 87. takže naozaj dlho. A ľudia, keď spomenieme 5G, tak si vždy tak trochu presne čalo.
They keep moving the target. So new challenges, but again, it's the same challenge. It's all about good radio performance. It's a radio system. It's not rocket science. Good signal to noise, good quality. That's the key.
A áno, aj keď je to 5G, tak stále je to o tom istom, je to stále o tom rádiovom signále, nie je to niečo, nevynachádzame vesmírnu raketu, je to stále v podstate ten istý systém.
The data is growing and growing, and the revenue is falling.
Že dáta nám rastú a ziskovosť nám klesá.
So you guys need more efficient backhaul and wireless solutions inside buildings.
Efektívnejšie ten backhaul.
But again, one thing remains the same, the RF performance is key. So, like I said in the beginning, do not focus too much on 5G. 5G is important, but it's going to take 5, 6, 7 years until you see real deployments out there.
Nezameriavajte sa zbytočne na to 5G, to 5G momentálne ešte taký zmysel nedáva. Ono, kým reálne sa naozaj dostaneme na ten trh, aby pre nás bolo užitočné, to bude trvať ešte tých 5-6 rokov.
So my best advice is for you to use your 4G network to a maximum before even investing in 5G.
Moje pekné odporúčanie, čo vám môžem dať ako radou, je, že skúste sa viac zainvestovať do 4G a naozaj dosahujte tú výkonu 4G na maximum, ktoré sa teraz dá.
So focus on quality and focus on cost per megabit.
Takže zameriavajte sa na tú kvalitu a na cenu, ktorú máte za megabit.
So the last thing I want to say, and I know this may be overwhelming for a lot of people, you can download our white paper.
Ďalšia vec, ktorú by som vám povedal, je, že pozrite si náš white paper, ktorý máme na internete.
But even better, you can talk with Pavel, and you can talk with me and Marcus. We'll be here a few minutes after the presentation also.
Hovoriť so mnou, môžete s Markusom alebo s Pavlom, myslím si, že všetci budeme ešte.
And that's it, what I have prepared for you this morning. So,
Všetko, čo som si pre vás dneska na obede pripravil, ak máte akékoľvek otázky, tak samozrejme sme to.
So any questions? You can ask them in English.
Sa spýtajte po akékoľvek otázky v angličtine, ale aj v slovenčine.
Tak ja sa pozerám na aplikáciu slajdov. Nemáme tam žiadny dotaz. Ja by som v Čechách a na Slovensku sa dosiaľ používa iba pasívny raz. Ešte na koaxiálnych kábloch. Je aktivní DAS nový? Už máme nejaké referencie?
That's a really good question. And active DAS is nothing new. The first systems was deployed 15-20 years ago. We have about 5,000 systems out there. We are servicing the most important sites in airports and sports stadiums for many of the operators around the world. Active DAS is nothing new in the market, but I understand that some people it could be a new system to use, and we have the training programs and the support structure to help you understand and help you plan these systems.
Active DAS nie je vôbec nič nové. Možno je to len pre niektorých ľudí novinka, alebo nie sú takové, že to používať, ale Active DAS je na tom možno 15 až 20 rokov. My sme máme veľa skúseností, inštaluje sa to viac ako na 3000 miestach. Máme skúsenosti hlavne pri väčších miestach, ako sú napríklad nejaké športové štadióny, kde sa tieto Active DASy veľmi osvedčujú.
And also we see a trend with Active DAS solutions. We see new players coming into the market.
Aj nových hráčov, ktorí prichádzajú na trh a vidíme ten zmysel v tom Active DASu.
The picture I showed you where you had 5 buildings serviced from one base station location.
Menete si ten obrázok, ktorý sme tu mali na tom jednom slade, kde bolo práve tých 5 budov, celé to bolo napojené na jedno miesto.
That's what we call, you can do it as a mobile operator, but normally we have what we call a end-user host.
My to voláme tzv. End-user host, môžete to robiť z jedného operátora.
And this could be a company that owns a lot of fiber in the ground.
Môžu byť spoločnosti, ktoré obsahujú veľa vlákien na zemi.
So they will build a base station hotel, and they will use that base station hotel and their fiber to transport the coverage capacity to the building.
Že môžu mať nejaký base station niekde a môžu sa napojiť na konkrétnu budovu.
Or rather, a number of buildings
Alebo na celú množstvo budov.
up to 20 kilometers away.
Dokonca až do vzdialenosti 20 km.
So the mobile operator only have to invest in a base station connected at the central point.
Takže keď si to uvedomíte, tak ten operátor sa musí napojiť iba na ten base station, na ten bod napojenia.
And then he rents connectivity to these buildings.
Potom si prenajme to napojenie do tých budov.
And sometimes even the building owner will invest in all the active elements inside the building.
Niekedy aj tí majiteľia budov investujú do samotných do toho napojenia v budovách.
So with one base station location,
Z jednou base station
the mobile operator will get access to multiple buildings with low and below investment.
sa ten konkrétny operátor vie napojiť na celú sériu budov a bez toho, aby to bola pre ňu veľká investícia.
But everything, of course, is 100% in control of the mobile operators in design levels, KPIs, control of the spectrum and the channels.
Samozrejme všetko, či už sú to KPI alebo nejaká výkonnosť, všetko to závisí od toho konkrétneho operátora.
Ďakujem veľmi pekne. Aj vám patrí ako poďakovanie tričko, takže aby ste mali pamiatku na dnešnú konferenciu. A pán Muzikant, ten sa zaoberá optikou, takže